Today we are talking about transformations of absolute value functions. Now we're going to go through the rules of transformations, and we're using the absolute value function form, but these rules apply to every function regardless of what they are, and as we introduce new functions we'll show how they apply to those also. Yesterday we used a Desmos activity to explore these rules. Today we're just writing them down. Let's start with the first one. F of x equals x minus c. So when the minus c is inside the absolute value, that's a right or left movement. Minus c means to the right. F of x equals x plus c. This translates left c units. So what I want to be sure that we see here is these two, that's a bad bracket. These two here are inside the absolute value sign. Minus moves it right, plus moves it left. So inside it moves opposite what you think it should, or what the signs tell you. Okay? Inside is left to right and moves opposite of the sign. F of x equals the absolute value of x with a minus c outside the absolute value. Translates down. Okay. F of x equals the absolute value of x plus c. That translates up c units. So inside moves right to left, outside moves up and down. Now f of x equals negative absolute value of x. This reflects over the x-axis. So this is what in geometry you may have called a flip. So instead of the absolute value graph going in an upward direction, it is going to flip it down over the x-axis. Okay, that's an x. Now when we put the negative inside the absolute value, so f of x equals the absolute value of negative x, that is going to reflect over the y-axis. But when the negative is outside, it's reflecting over the x-axis. So this one, let me scoot over here a little bit. Actually, on this reflection for the absolute value, since this is the parent function, if we reflect the parent function over the y-axis, we actually just get the same thing back. If we take this side and reflect it over the y-axis, it goes there. And if we take that side and reflect it over the y-axis, it goes there. So the reflection over the y-axis is not really visible on the parent function, but as we translate it right to left, we would be able to see that. All right, so if f of x equals a times the absolute value of x, we have a vertical stretch if a is greater than 0. In other words, numbers bigger than 1 are going to make the graph, let me draw you, here is the parent function. Oops, no it's not. Sorry. Here's the parent function. We're going to do a vertical stretch, which means it's going to get taller, okay? A vertical compression happens when we have a factor, when a is a factor between 0 and 1. In other words, these are fractions or decimals. So a compression, if this is our parent function, is going to get compressed vertically, okay? Now, it is very important you keep the word vertical in front of these when you describe them. And notice that both of these are by a factor of A. A is this number right here, so whatever that number is, you are going to plug it in by a factor of this number. All right, so here are our rules. I have given you the actual terminology that you need to use to describe the transformation. So let's go ahead and do some examples. So here's our first example. Now, easiest thing to do with these is go one step at a time. I notice that I have a -2. Now, anything that's inside the function or inside the absolute value in this situation is going to go opposite the sign, and it's always going to go left or right. It's side to side. So what this is a translation. It looks, because of the negative, it looks like it's going left, so we are going to go right 2 units. That's how you would describe that. Now, as we continue to move to the right, outside the absolute value, we have a -4. What's outside the absolute value goes up and down, and it does exactly what you tell it to. So this is a translation. It's positive. Up is the positive direction. So it's a translation up. Oops, sorry. That is a minus sign, so that indicates it's going down. A translation down 4 units. That was the end of our equation, so we are finished with example 1. All right, you need to use this terminology. So let's do example 2. Okay, example 2, describe the transformation on h of x equals -0.5 absolute value of x plus 3. Again, we're going to go one thing at a time. I have a negative right here. The negative in front of the absolute value tells me to reflect over the x-axis. The 0.5 that is being multiplied out in front, if you look back at your notes, this tells me because it is between 0 and 1, it is a decimal, so this is going to be a vertical compression by a factor of 0.5, because that is the value of A. Okay, then outside the absolute value, I have this plus 3, so that is a translation, and outside, everything does what it's supposed to, and it goes up or down, so a translation up 3 units. You get the idea of exactly what it is that we need to be describing and how we are to describe it. So let's do another example. Okay, here's example 3. Describe the transformation on f of x equals 3 absolute value negative x plus 4. So again, start here and just go left to right. Go ahead and hit pause, and when you're finished, hit play again and check to see if you have it right. Do this one on your own. Okay, so you should have a vertical stretch by a factor of 3 because the A value is bigger than 1. You should have a reflection over the y-axis because it's inside the absolute value, and a translation left 4 units because inside the absolute value, those signs do opposite of what you think they should. So good job. Okay, the last example, I want you to write the equation f of x of the graph that has been transformed by translating down 7 units, translating right 3 units, and reflecting over the x-axis. This is just doing what we've done on examples 1 through 3, but going backwards. You were describing after I gave you the equation. Now I'm describing it, and I want you to give me the equation. Hit pause, try writing it, and then hit play again to check your answer. Okay, the equation you should have is negative absolute value of x minus 3 minus 7. So let's make sure we got this right. We translated down 7 units. Here's your minus 7. We translated right 3 units. Here's your minus 3. We reflected over the x-axis. That negative out in front is your reflection. Good job.